Okay, so let's name this. It's technically a sub-assembly, so we're gonna rename it. We're gonna go hammer sub-assemb for sub-assembly. Now it's time to create our chassis. Chassis, the supporting frame of a structure, right? So the frame and working parts. Yes. So usually it refers to cars. In this case, it refers to the robot. So let's create a new part. So we got create part studio. Nice. And we'll bring it all the way over here, and we will name it chassis. And we will go new sketch and normal 2. And let's start with a rectangle. And let's reference our SketchUp model, right? So we're back in SketchUp here. If I click on a line and hit measurements, I think it will give us the dimension. Yeah, I think it's 9.4. Yeah, 9.47 inches. So let's just call that 9.5. Let's come back over here and let's call this 9.5. And let's go back to SketchUp and let's see what SketchUp says about this other line. And let's hit measurements. And here to here looks like 5.285. So let's call it 5.25. So 5.25. Very good. And then let's roughly get the distance from here to here, about 9 inches. Okay. So if we draw our rough triangle shape like this, sorry I didn't attach these 2 points. I can drag that over until they snap together. Yep, there we go. So the overall length here is, what was that again? 9 inches. Okay. So we got 9. Okay, good. And now we know this has to be symmetrical, so let's draw a line that goes for construction line. Hit Q. It goes from the midpoint up to the middle. Okay, so instead what we can do is we can delete this line. We can create 2 lines and then make them equal. So we'll select both of them and hit E. Now these 2 lines are equal no matter what we do. They should also be parallel. Okay, good. Good. And now we can put this, which is now by definition the midpoint, in the middle. Nice. Okay. We did not define the distance here as 9. Yeah, 9. There we go. Okay, that looks more correct. Okay, good. So now let's extrude this. I think I remember it was 0.375. Okay, so now this is like the basic outline shape. So now what we can do is we can go into, we'll name this the master assembly. Master assembly. Nice. And let's insert that part, the chassis, as the first one, because that will help us have something that's kind of fixed in space. So we're going to right click and hit fix. Nice. So now you can tell if you try to grab this and move it around, it doesn't move because it's fixed. You go to insert and we can grab the gearbox. Very good. And let's grab the wheel. Nice. And let's grab the motor. Sweet. So now for us to mate things together, we want to use the planar mate usually, and just select the surface that you want to mate it to. So this is the bottom of the gearbox. Bottom gearbox goes on the top surface of the chassis. Now that's obviously not the way that we want it. We want it on the top, right? So you have to hit this reverse button, flip. Yep, exactly. So now it'll be flipped and on the correct side. And don't worry too much about the orientation right now. We're just trying to mate things together. So now we want to go to our, there should be a cylindrical mate. Yep, cylindrical. And select the, the outside circle here. So this is the cylindrical surface that goes all the way around. And then select this cylindrical surface. And it will mate these two together in a way that they're stuck. So, but don't be fooled if it goes in the right position the first time, because you see how I can actually grab it and it will move away. So we don't want that. So what we want to do is we want to do another planar mate, but this time we want a little offset, which means that there's going to be a little space. So we select this surface over here, we select this surface over here, and now they're completely together, but we don't want them touching or rubbing, right? So what we actually want is we want an offset. So we want, I don't know, maybe a 1/16 of an inch. But it's the wrong way, right? So these just went a little closer together. We have to flip it. Maybe we need to make it a negative number. Okay, so in order to flip it, you actually have to make it a negative number. So if it goes the wrong direction, just put a minus sign in front of the 16th. Yeah, there we go. And same thing here. We want the motor to be mated cylindrically. So these are concentric. And we're going to click on the outside cylindrical surface. Click on this outside cylindrical surface. Nice. And now those are together too. And we can pull this one out. And now what we need is for this plane here to go to this plane. Nice. Okay, so now we've got our our motor unit. And as you can see, when you don't have a reference point, sometimes things can get moved along kind of weirdly. Okay, so let's put in another planar mate here. And this time it's going to be from this end of the gearbox to this end of the base plate. So this is one of the things that I hate about Onshape, is that it doesn't keep the whole assembly together. It looks goofy. You go, okay, but that's not how it actually solves the mate, which is interesting. I'm not an expert in Onshape by any means. I feel like I know SolidWorks better than Onshape, but there's a lot of advantages to Onshape, like the fact that you can just use it in your browser. You don't need a super powerful computer with a nice graphics card to use it or anything. So we have to select this, and you kind of have to snake yourself in here so you can see the surface and click it. You go OK, and that looks pretty good. Alright, so it's probably better to make this a sub-assembly and then insert it that way. So let's go ahead and we're going to delete this part, delete this part, delete this part. Okay. See how all the mates also went away? Once you delete the things that things are mated to, that's what causes them to disappear. So let's go over to create assembly, and we're going to name this one drive, gearbox, wheel, motor, sub-assem. Nice. Alright, so let's insert our gearbox. Let's insert, not the chassis, but the wheel. We can delete that later. And we'll put in the motor. Go ahead and delete that. We're going to fix this in space. We're going to grab the cylindrical mate, this one over here, this surface, very good. And now we're going to do our same planar mate with an offset from here to here. And what's our offset going to be? It's going to be about 1/16 of an inch. And again, it's trying to put it into the gearbox as opposed to away from it, so we got to put a negative sign here. Yep, there we go. So that looks good. Now let's do the same cylindrical mate with here and here. Excellent. And we're going to drag this out, and we're going to do another to this. Okay, excellent. And now this is the sub-assembly that we can use to attach into the master assembly. So let's go to master assembly, go insert, go to assemblies, drive gearbox. Nice. And we're going to have 2 of those. And once again, we're going to go to our planer mate. We're going to have this part of the gearbox be on the bottom. Okay. And we messed up here. See here it and we messed up here. See it attached to the bottom side. So we have to flip it. Go okay. Yeah, again, I don't really know why Onshape does this thing where it doesn't really solve the entire mate so that you can't like preview it, but it just doesn't. So, I don't know. Maybe I'm doing something wrong. I don't know everything about Onshape, so. Okay, so there we go. That's another planer mate over here, and this is now pretty much fully constrained to this corner, which is good. And let's grab this bottom surface, mate it to this surface. It's going to be planar. We'll go okay. It did the exact same thing where it's on the wrong side. So we got to flip it. Good. And let's planar mate again. This side over here. Again, it's doing weird stuff with the direction there. And again, let's sneak in here. Try to click on that surface. Nice. And over here. And there we go. Okay. No big deal. So this is coming together. Let's insert another gearbox and another motor. So let's go gearbox and motor. Good. And let's go to our cylindrical mate. We're going to mate these so that they're concentric. We can bring this down. We're going to mate the planes from here to here. Now those are touching. Now we're going to put this onto this surface. And let's just flip it to begin with because that seems to be what it wants us to do. Now, if we don't want to actually make this stick to anything, we can do a parallel mate. So, parallel over here. Basically, we can take this surface and this surface in the back here, and we can make them parallel. So what this will do is it'll let us move the gearbox around. So we can move this wherever we want without it being actually stuck. With the planar mate, you actually have to have the 2 planes touch each other at all times. With the parallel mate, you can have 2 planes just always be parallel. So now this will move around a lot easier. Okay, so if we want to have this be a certain distance, we can do a planar mate and hit the offset button. So here we'd use -1 inches because you have to use a negative sign to tell it which direction to go into. If it goes in the wrong direction, just throw a negative sign in there. Okay. So now we can move this around, and we want to design a part that is going to allow us to hold the hammer. So basically, we're going to design something that we can put a whole bunch of zip ties in and use that to attach to the gearbox and the hammer. So let's go ahead and do create part studio. I said let's create part studio. Good. Okay. And now we can go to the top. And we can go to the top. Alright, so now we're in a new part studio. Let's go new sketch. And we'll hit N just for our normal 2 view. And we're going to create the reverse of the keyway here. So 0.5, 0.51 inches, 0.5. I think that's pretty safe as the internal diameter, so it'll fit on the 0.5 inch shaft. And we want to have this be pretty thick because we're going to make it 3D printed. So you always have to make plastic parts way thicker than you would for metal parts. Even 0.5 inch thick. What is the orbital diameter of that, I wonder? 1.5, that's too large, right? Because that will be bigger than the gearbox height itself. So let's make it 1.3. Yeah, let's make it 1.25. Okay. There we go. So these need to be put in the same center point. Okay, good. And we can extrude this. We can make it a solid, I think 0.75 inches thick. Yeah, that'd be pretty good. We could even go thicker than that, I think, actually, if we really wanted to. Yeah. Alright, 1 inch. Like I said, plastic parts, you just have to make them way thicker. So they'll be stronger. Okay, so let's create the keyway here. Complementary keyway. So I'm creating a rectangle. I'm going to split the rectangle in half so that we don't put it on two sides. And I'm going to make the height here 0.125. And I'm going to make the width 0.125. And we're going to use the remove tool, remove. And we don't want to remove it down here, we just want to remove it up here. And yes, we want to go pretty much the whole inch all the way through. It has to actually be 0.625, doesn't it? So let's go back into the sketch. 1/16 of an inch, yeah. Because remember, it's half of a keyway. Yep. Good, good. Alright, I'm pretty sure we can force the, so whenever you 3D print stuff, sometimes the plastic over extrudes so that internal dimensions will be a little bit smaller than they are in the CAD program, but you should be able to just kind of snap it in there, force it in there. You can always print another piece, so. And I think I'm going to change thickness back to 0.75. Yeah, that's good. Okay. Now this has to be attached to something that's going to hold the hammer. So let's go to the back side of this and view normal 2. We're going to sketch. We're going to create another rectangle. Nice. And I want this rectangle to be tangent to the circle here. Nice. And what we can do is you can actually click on a sketch, or rather an edge that's not in your sketch, and hit this button, convert or project, and it will pretty much turn whatever edge that is into a sketch that's on your plane. So this will be useful because now I can make a surface that will follow this exactly. And I think that if we have a solid, how long should this be? If we go from here down to here. Yeah, I think 3 inches of arm to grab onto the hammer is reasonable. Could make it longer, I guess, but let's just make it. Let's make it 5, just to be safe here. Okay, that's good. And we're gonna extrude this, and this is going the wrong direction. We gotta hit the flip button, and it's a little too far. So we can actually change, instead of doing a blind dimension, we can go up to face, and then we can click on this face, and it will only go up to there. And then if we change this thickness, it will automatically change as well. Okay, so actually I've changed my mind. I don't want that to be all the way up to that face. I do want it to be blind, and I want it to be 0.375. So that's 375. 100 times. More than that, actually. Okay. 1,000 times too big. So that looks pretty good. And now I'm going to put holes in here that we're going to use to strap zip ties around the hammer. So I'm going to do another sketch. I'm going to do another rectangle, And let's just look up some dimensions of zip ties. Create a rectangle. We can move that down here. We can hit D for dimension. We can do 8 millimeters. And this is going to be 2 millimeters. Let's make it 2.5 to be safe. Nope, not 2.5 inches. We want 2.5 millimeters. And that was the wrong dimension. There we go. Okay. So there's our rectangle. And let's hit rectangle again. And we'll kind of line them up on the same axis here. We're going to make these equal by just clicking them and hitting E. Hit this, E. And we're going to give them the same distance from the edge, which is going to be something like 0.2. 0.125. Let's do 0.15. 0.15. There we go. Okay. Same thing over here. Here we go. 0.15. And now I'm going to dimension this from the top. Just from the edge. Same thing, 0.15. Okay, good. So now we have 2 sets of holes, and let's remove the material here. Yeah, it goes all the way through. Great. Now I want like, I don't know, 6 of these, right? So what we can do is we can actually make a linear pattern. So we can pattern these, go 1, 2, 3, 4, 5, 6 all the way down the line. So to do that, we go over here to linear pattern, and it's not a part, it's a feature. Again, Onshape not defaulting to feature, which I think is a little stupid. And we've got extrude number 4, we got direction, and for direction you just need to put the click on edge or a line that goes in the direction that you want it to go. See, like it just put it in this direction. So let's decrease the distance between them a little bit. So that's 0.75 inches. Let's increase the number of them that there are. So this is 6 of them all in a row. Maybe we increase that to 8. Can we get 8 on here? 8 is too many. So let's do 6, and let's increase the distance just to 0.8. Okay, let's do 0.9. Maybe just decrease the distance a little bit here. Nice. Okay, 0.8 is pretty good. Excellent. So now we got a whole bunch of holes. A whole bunch of holes. Now we got a whole bunch of holes in the arms. These will be for, like, slots for zip ties. You can stick zip ties through the middle of here, and we can attach the hammer that way. Very good. So let's go back to the master assembly. We're going to insert our new part. We're going to find, so we didn't name this yet. Let's just go back and name it. Part Studio 1. Rename. This is going to be hammer zip tie arm. There we go. Okay, we'll get a cylindrical mate over here. Any cylindrical surface, doesn't have to be a complete circle, will work. So this is kind of, yeah, that looks pretty good to me. And the thing we're seeing here is that when you try to drag one thing and they both move, they don't always move at the same rate. So just watch out for that. It can be hard to stick stuff together. So we're going to go planar, planar, and what we want is an offset, and I don't know, maybe like a 1/16 of an inch. That seems like enough clearance, but it's in the wrong direction. So we're going to hit the minus sign, and there we go. So this will now be a 1/16 of an inch away from that surface. And let's go ahead and put the hammer in here. So we want to go to assemblies, remember, because we want the hammer assembly, not just the hammer handle or the head. And we'll hit planar mate. We want this side of the hammer. Grab that plane, connect it to this one. Very good. Okay. And, oh, clearly something is wrong with our hammer head here. So see how it's disconnected? So we need to go back to hammer subassembly and see what, okay. So we forgot to constrain the hammer head here to the rest of the surface. So we're going to edit each of these individually. So let's make things easier on ourselves, and we're going to edit this part. So you can double click on a part and we'll open that part. We're going to go right up here. We're going to go view normal 2. We're going to sketch on here. We're going to create a circle, and we're going to put our circle right in the middle. And we're just going to do a little removal here of material. So what this is going to do is this is going to give a little circle in the bottom of the hammer. And we're going to go to the hammer head, and we're going to do the exact same thing. We're going to view normal 2. We're going to sketch right here. We're going to create a circle. We're going to go to the midpoint here, try to get them to line up. And 0.5, and we're going to do a little adding, maybe 0.125, 0.25 inches, just like that. Nice. We're going to go to the hammer subassembly, and now what we can do is we can grab the cylindrical mate and go from here, all the way to here, and now these will kind of line up like a pin. It still rotates though, so that this head is not constrained, besides the circle. So now what we do is we take this surface and we take this surface, and we can make them parallel. So we grab a parallel mate here and here, and now this is not going to move anywhere. Nice. Okay, so let's go back. Okay, so because we don't have any fastening holes, like holes that are drilled into the hammer here that correspond with the arm, we could do that. We could dimension 2 holes here just for lining stuff up. But what I want to show you guys is how to mate stuff together without actually connecting anything at all. So if you just drag and rotate stuff into position, you can actually just fix 2 parts relative to one another with just one mate. It's called a group mate. So we're going to go like that. Yeah, it looks pretty good. So now basically I want these 2 parts to be fixed in relation to each other. So we're just going to select both of them. We're going to search tools. We're going to type group. We're going to hit the group button here. And now we hit OK. And now what this does is the hammer and the arm are now fixed in space, however they were when we put that in there. So this is what this looks like. And now we can rotate it around. And we can kind of see that if we put this all the way down, there's not really enough space here for the hammer to go in between the motors. So here's something really good about parametric modeling that we can showcase. So let's say that we got to this point, right? And now we decided, oh no, I actually wanted the distance between the motors to be bigger. Maybe we want them to be, I think it's like 9 inches right now. We want to be 10 inches. What we can do is we can edit this part. So if we double click on that part, it will open up the part studio. And it will actually show, as an overlay, the master assembly. So it's showing the assembly, and you can change the transparency here. So you can make it not transparent at all, or you can make it completely like a ghost. So here we can actually see how stuff will update. So I'm going to keep it with this transparency, but keep in mind we're only editing the part that's solid here. So what we can do is we can go to Edit Sketch, and instead of this being 9.5, let's make it 10. So now this is going to be 10 inches instead. And we hit OK. And you see how it hasn't really shifted over yet? So now what we can do is go back to the assembly, and once we go back to the assembly, it will automatically update. So you can see over here, now there's more space in between the two motors, but because we defined the motors as, being sharing these two planes and sharing, these two planes on the side, that's where they will stay. They'll stay locked into that corner. And now we've gained, space in the middle here, which is good. So we've got enough space for the hammer, we've got enough space for the motor. What we really want to do now is lock the motor into place. Okay, so to make this gearbox stay in the same place, so it doesn't slide left or right, basically I just made a planar mate, and I connected this surface to this surface. I put in an offset of negative 0.5 inches, and that puts the hammer pretty much right in the center of the two motors. Let's move on to putting holes in the chassis.